Good morning, 8th grade. We're going to go ahead and finish up section 4. You can see that I have set myself up by writing number 3, and we're going to talk today about something called constraints and viable solutions. And I've put a letter A, and this is a cutout from the previous set that I had given you. If you didn't save it, just go ahead and reprint out that page, and it's the last two that we're going to be dealing with today. Okay, so we are going to go ahead and get started. It says the local zoo is filling 2 water tanks for the elephant exhibit. One water tank contains 50 gallons of water and is filled at a constant rate of 10 gallons per hour. The second water tank contains 29 gallons of water and is filled at a constant rate of 3 gallons per hour. When will the 2 tanks have the same amount of water? Okay, so we're going to go ahead and figure out what our 2 equations are. Actually, before that, we need to define our variables. So let's go ahead and do that. I'm just going to use x and y. Always a good go-to. So it says when, so that's an amount of time. So I'm going to say that x is going to be the number of hours. Okay? And y is going to represent the amount of water in the tank. Alright, so I have my 2 variables. I don't know what I spelled here. That's supposed to say water. There we go. Okay, so let's write our 2 equations. We'll say this is tank 1. And we'll do tank 2 over here. Okay, here we go. So the first tank, the amount of water is 50 gallons of water. So that's already in there. That's already there. And it's filled at a rate of 10 gallons per hour. So each hour, it's going up by 10 more gallons. So that's what our equation would look like for tank 1. Pause, take a moment, move this down a little bit, take a moment and see if you can figure out on your own what the equation for tank 2 would be. So pause the video, see if you can figure it out. So for tank 2, it's going to look similar. The amount of water, we started with 29, that's already in there, but it's filling up at 3 gallons each hour. So here are our 2 equations. And there's a key phrase in the very last sentence of this. When will the 2 tanks have the same amount of water? That means since y equals these 2 different amounts, I can take these and set them equal to each other. Because I want to see when they will be the same. Okay, and now it's an easy, multi-step equation. Well, let's go ahead and figure it out. I'm going to subtract 50 from both sides. I get 10x equals 3x. This would be minus 21. I subtract 3. From both, 3x from both sides, and I get 7x equals negative 21. Divide by 7 on both sides, and x is negative 3. Good. So let's go ahead and take our negative 3. We'll plug it into one of our equations and figure out what y equals. I'll just use the first one. You could use the second one. There's nothing stopping you from doing that. If your solution here is correct, then you should get the same amount for y, no matter which one you plug it into. So we'll do y equals, instead of 10x plus 50, it'll be 10 times negative 3 plus 50. So y equals negative 30 plus 50. So y is 20. So our solution here is negative 3, 20. Which, if this was just two equations would be fine. But we are talking about an actual event here, a real-life situation. Remember what x represents, the number of hours. Can I have -3 hours? No, that is not possible. This is what we call a non-viable solution. Non-viable solution. Because while mathematically it works, it doesn't make any sense in real life. I can't go backwards in time. That's not going to happen. So, when we answer the question, when will the two tanks have the same amount of water? They won't. They never will. Our solution doesn't make any sense. The tanks will never have same amount. It's just not going to happen. Okay, so what would the constraint be on this particular situation? It's actually pretty easy to figure out. If x represents a number of hours, well, any x value would have to be positive or 0. So the constraint would be x has to be greater than or equal to 0. That's the only way this is going to make sense. We got -3 and it didn't make any sense because you can't have negative time. And y represents an amount of water, so it's the same thing for y. Y has got to be something that is equal to or bigger than 0, or it's not going to make any sense. Let's try another one. This will be your next cutout, and it'll look something like this. So I'm going to pause and glue in. Please do the same. Alright, so I have mine glued in. This one's going to be kind of similar. So it says the zoo has 2 other water tanks that are leaking. One tank contains 10 gallons of water and is leaking at a constant rate of 2 gallons per hour. A second tank contains 6 gallons of water and is leaking at a constant rate of 4 gallons per hour. When will the tanks have the same amount of water? Explain. So, it seems like we're dealing with the same variables here. So I'm still going to use x and y. And x is still going to represent the number of hours that it's going to take for these tanks to, in this case, be empty. And y is going to represent the amount of water, I almost put number of water, amount of water in each tank. Alright. So again, we're going to set it up for tank 1 and tank 2. So before I go ahead and write the equations, I want you guys to pause and see if you can figure them out on your own. I'm going to pause and write them down. You pause and see if you can figure them out by yourself. Okay, so these are the 2 equations you should have. You might have had something slightly different. Maybe you had y equals -2x plus 10 and y equals -4x plus 6. The reason it's negative is because these guys are leaking at a constant rate. So if it's leaking, it's going down. Alright. But if you notice, we're still dealing with the same variables. So the constraint on this, if it's hours, well, x still has to be something that's 0 or bigger. And same with y. It still has to represent something that's 0 or bigger. You can't have negative gallons of water. You can't have negative number of hours. So again, they're asking when will they have the same amount of water. So we're going to set these equal to each other. This is substitution. So I'm going to use this one, 10 minus 2x equals 6 minus 4x. And then I'm going to solve. I'm going to add 4x to both sides. I get 10 plus 2x equals 6. Subtract 10 both sides, 2x equals -4. And if I divide by 2, I get that x is -2. Slide that down a bit. Now I'm going to plug in -2 and see what my y value would be. I'll use my first one, y equals 10 minus 2x. There we go. Y equals 10 minus 2 times -2. Y equals 10 plus 4. So y is 14, which means that our solution to this would be negative 2, 14. However, we've already said, since x represents a specific number of hours, it can't be negative. It's got to be 0 or bigger. I can have 0 hours, or I can have more than that, but I can't have negative hours. We can't go back in time. So, when will the tanks have the same amount? They never will. The tanks will never have the same amount. And if you, can't spell. If you think about it, that makes sense. The first tank's got 10 gallons of water in it, and it's leaking at 2 gallons per hour. That means in 5 hours' time, it's going to be empty. The other tank has 6 gallons of water in it, and it's leaking at a much faster rate, 4 gallons per hour. So in about an hour and a half, that one's going to be empty. So yeah, it makes sense that they're never going to have the same amount in there. Alright, so I'm going to have you guys pause. You're going to practice that same set of IXL topics that you were working on yesterday, because I really want us to get down, working on the word problem. So you're going to head back over there once you're done with the video.